today is Thursday, and you know what Thursday means? Trash day. Oh, well, that's in our household, but as far as the videos go, yeah, the videos, that's different. Thursday and Friday are our last 2 days of the public videos, and then Saturday through Monday, those are reserved for our supporters. That's when we have our bonus videos that are private, and if you're a supporter through Patreon, and I'll pop up this link here, you will get access to those automatically. So that's well worth considering if you enjoy those videos. Anyway, we've got a little Altocumulus castellanus up there due to some mid-level instability, and let's take a look at the charts and see what's going on. All right, we got a lot going on the Great Plains today, so let's check it out there. 1003 millibar low around Tucumcari, just north of Clovis, and we've got a cold front extending westward. We can see the wind shifts. Got northwest winds to north winds from Gallup to the Grand Canyon to even Vegas. And then south of that, there's mostly a westerly flow. And we got very warm conditions at El Paso where it's 97. The dry line is established. We see that running from a triple point around Shamrock, down through Childress, down to Big Spring, and around to Sanderson. Just east of there, we've got a fresh maritime tropical air mass. The dew points are only in the upper 50s along the Interstate 20 corridor, and it's only down along Interstate 10 where we get into the 60s. So this is a relatively young return of tropical moisture. We've got a warm front extending from that triple point at Shamrock to about Gainesville and near Shreveport, and north of that, some mild conditions, 60s and 70s in Oklahoma. And then far up to the north in Kansas and Nebraska, some sort of front that I haven't really looked into detail at. West of there, we've got downslope and lower 60s, and east of there, some humid, cool conditions. And some of you may be wondering about these string bean pressure areas. That's just a numerical artifact. I try to run a very detailed analysis scheme here, Cressman, with a lot of smoothing, but only one smoothing pass. In this areas where there's not much data, we get these artifacts, but that gives us the advantage of giving some very nice detailed fields where there is data. So that's kind of a compromise I'm making here. Here's a pattern across North Texas, Oklahoma, and Kansas. Some elevated convection up there near Russell, down to Wichita. We know that the warm front is running somewhere in the Red River region, and the low pressure area out there in the dry air. Let's run an animation and see what's going on. You can see a cumulus field developing there along the cap rock, just off of that, and a little what looks like jet streak across Amarillo. Some upper level lift and little moisture associated with that, and then running that up to the current time, we see the establishment of some convective fields out around Memphis, Texas, down to Clarendon, and then some higher based Q around Clayton. So we are early in the convective day, and we remember from yesterday's models that we're expecting development somewhere in this area, possibly on the cap rock, and then moving off into the northwest Texas and southwest Oklahoma region. The next step in our analysis, now that we know that there's not much showing on satellite, is to look at the mesoscale analysis. This is from Texas Tech, and I'll give you this link in case you want to go to that. You can freeze frame the video and put that in. So anyway, let's move on. We see dry line air back there around Amarillo and along the interstate leading down to Lubbock. So we don't have a lot of convergence along that dry line. One thing that I'm seeing is the winds in the moist sector are running like that. Winds in the dry sector are like that. Typically, whenever I see that, that means initiation is going to be very late in the day, if at all. I like to see much better convergence if we're going to get initiation. So I think we may be having some issues as far as that goes, although the models are pretty firm in developing convection. It appears the dry line runs about like that, and the warm front seems to get kind of smoothed out. We're kind of looking at an elephant with a magnifying glass, and then the warm front kind of like that, but I think it may be carried north as a warm front, at least temporarily. And then we can look over there on the Oklahoma Mesonet. Now, the dry line is going to be off the chart, but this will help us find the warm front. And I think I'm seeing something like that for the warm front position. It's in the... And I think I'm seeing something like that for the warm front position, the southern tier counties of southwestern and south central Oklahoma. And those are some very stout winds there. Lots of gusts up to 35 knots, and I think maybe the highest I'm seeing in here is 37. That looks like around maybe Mangum. And then checking back at our surface map, yeah, that kind of matches up. But it does look like this segment of the front is being carried northward just a little bit. So maybe the surface low is still way out to the west. The other question is, what boundaries are out there, and what other tools can we use? Well, there's also radar. We got the Amarillo radar. What would we expect to find? Well, that might pick up the dry line, although with the winds kind of parallel along that boundary, I would not expect that to show up very well, especially at that range. The Frederick radar is right there. That would probably pick up the warm front, but even there's not a whole lot of convergence. And that leaves us with Lubbock and the Dias radar. So I'm not really expecting to find much on the radar. It's always a good idea to work up your expectations before actually going to the products. So that way, that gives you a way to compare and contrast different sources. And there's the Frederick radar, and certainly not seeing any boundaries on that. We can look at the velocity too, just showing a straight, slight south-southwest flow there, and just a very small amount of turning in the winds as you go up with height. See, up at about 5,000–6,000, we're out of the southwest, and out of the south-southwest, can't seem to draw a straight line, yeah, down there near the surface. Let's try that one more time. There we go. So very slight rotation from the low levels to the getting near the mid levels. We'll try Amarillo, and I'm not expecting to see anything there either. Now, it's possible that if storms are starting to go up, oh yeah, there's a boundary right there. So yeah, we're picking up the front, but we also may start to see the convection going up, so we're going to be looking for that. But at this time, not much going on. But we can go to the spectrum width, don't see much. Sometimes the correlation coefficient will show some evidence of the boundary. Okay, we've only got 2 frames to animate, but it looks like kind of a very slow northeast drift on that boundary there, which is probably the front. And we know that that's going to be in Hartley County. We know that that's a potential source of convection, though this is back in the dry line air. And we're not picking up the triple point really, or the dry line, because that's down in this area, and we're not sampling the wind field very well. So this is when you want to go back to your satellite, and we've got an image that is about 6 minutes old. And we can animate that, and we're starting to see a little bit of elevated convection developing in that area right around Memphis, just off the Cap Rock. Looks a little bit high-based at this time, so, you know, we're still kind of early in the convective day, but that's a cloud field that we want to watch. And we know that the triple point is right in that area there, dry line extending south, and we may see those boundaries start to firm up a little bit, and maybe some towers starting to go up also further to the west towards Amarillo, which is located right there. We could also see some elevated convection even further back. Really depends on how much upper level lift and destabilization we have going on. But the primary area is right there. And if that warm front is lifting to the north, we may see that region shift up into this region here. So possibly carrying north to Wellington or Shamrock. And this is a good time to go to the experimental tools at SPC. You can go to the Mesoanalysis graphics. And I've talked about this on previous segments, and I like to look at fields that help me find the boundaries. Velocity tensor magnitude is one of them, and that pretty much shows the dry line very well. And I can see some of that convergence along, let me do that a different color, along that frontal boundary right there. You can see the wind convergence. So that kind of can help refine our analysis. Another tool that I'll use is divergence and vorticity. So here we've got vorticity in shaded colors. And another tool that I like to use is divergence. The shading that you see here, the greens and yellows, those are vorticity. The red lines indicate convergence. So what is this telling us? Well, for one thing, I don't see any well-developed point convergence. I do see a kind of a very noisy field out to the west, and with the absence of convection right now, I think this indicates that there's some dynamics working on that area west of Amarillo. So things are still kind of boiling and coming together. Also, I don't see much going on east of Amarillo, and not much convergence along either the warm front or the dry line. In fact, it's almost a complete absence of convergence along that warm front. So I'm expecting the dominant process to be development along the mesolow, which is kind of being hinted at right there. Looks like maybe another mesolow around Lubbock. And also possibly development along the dry line, although there's not much convergence showing except right in this area here. I guess that would be around Turkey. Lift along the caprock become an important feature, although the winds are out of the south. Orographic lift is not really that strong. With the south wind, we need a southeast or east wind to really pull that together. So I'm looking at things firing back west, maybe towards McLean or Clarendon, maybe in that area, and possibly back towards Amarillo and Plainview. Yeah, so this is definitely pointing things a little further west. And then we compare that to the satellite, and yeah, we've got towers going up along the caprock, sort of. Not much showing up back here since it is still dry. So I think we're needing another hour or two for things to kind of coalesce. All right, so let's see what the models are showing. See if there's any updated models. 20Z. Well, we got a few frames there. Let's see what it's going for. All right, 4 p.m., no convection. 5 p.m., nothing. 6 p.m., nothing. One little speck there. North of Childress around 7 p.m. Now, I saw the frames earlier. They were going a little more aggressively for development. 20Z, 21. This is the previous run. 5 p.m., 6 p.m., 7 p.m. A few specks there. Southwest Oklahoma. Okay. So a very late development around 9 to 10 p.m. out around Elk City. Okay, so this falls in line with the poor convergence along that dry line. Okay, we got another frame here. Let's see what the latest frame shows. Yeah, speck there, 8 p.m. around Altus. So we are having trouble, and let's find out why. Let's back this up a little bit to 5 p.m. and sample the air around north of Childress. The problem is we just haven't had enough moisture return. We have had some cap erosion, but yeah, these are some poor dew points. Right around 50, they do have some depth, but it kind of trails off with height. So it's not enough to break this minimal cap. Now we do have some fairly decent shear. In fact, 0 through 2 kilometer shear is pretty good. And we've got the storm motion off the photograph pretty good, and a very good hook shape. So that's really excellent. And you can see the SRH is 150 surface through 1 kilometer, and then 400s for the 3 kilometer layer. And we're still favoring a northwest flow situation. Storms moving towards the east-southeast. And another interesting indication here, you can see hazard type is none, and these significant tornado parameter numbers are pretty low. In fact, it looks like the low LCLs are a big problem. And we can see that the moisture is mostly 50s dew points. and it's very hot, almost near 90 degrees, so we're looking at a relative humidity of about maybe 30%. And the LCLs, look at that. 2 kilometers, that's about 6,000 feet. So if you look at any tornado climatology papers, 2 kilometers, that's going to be really kind of outside the bounds for significant tornado development. However, with it being dry and drier in the mid-levels, that could be a good downdraft cape scenario. And yeah, look at that D cape, 1700, which is very, very high. So I would expect some wind potential. Storms tonight may be outflowish, and we could have some bow echoes and derechos later tonight along that main MCS that develops late along that front. So let's see what SPC is thinking. They've got the convective outlook, enhanced risk. It's got a shape like that, so I'm thinking maybe they're anticipating kind of a bow echo situation. Let's go to that convective outlook, see what they got. Minimal tornado potential. Looks like that's focused mostly along the MCS later. Definite wind potential. And that hail may be shaped for any possible afternoon convection. So it looks like late tonight, yeah, we're looking at possibility of wind, and let's see what they've got. 30% significant wind. So let's take a look at the ARW. This is the WRF with sophisticated physics, and this is the run from 7 a.m. this morning. And let's just see what I was going for. There's 5 p.m., 6 p.m., 7 p.m., 8 p.m. That's very interesting. The ARW did forecast this difficulty with initiation. And it focuses things along the front around 10 to 11 p.m. up there near Watauga, and then moves an MCS into the Oklahoma City area around midnight, and then that propagates southeast into northeast Texas and just grazes DFW around 5 a.m., and the bulk of that goes into Louisiana and Arkansas. And you can actually, pick up the front there. Yeah, I've been impressed in the past with the ARW, so I may start looking at that more. And I think the ECMWF was doing a similar thing yesterday. It built up this big squall line that propagated southeast. Let's look at the European model. I'm not going to expect it to handle the mesoscale features very well, but this should be kind of interesting. Okay, so it was going for deep convection along that warm front triple point. This is 7 p.m. and then it developed the MCS pretty quickly in northwest Oklahoma, and that dropped south in line with the ARW. And as we can see, recent runs of the high-resolution rapid refresh were developing that triple point convection. There's 7 p.m., 8 p.m. So the HRRR has kind of fallen in line with the ARW. Well, we can't totally rule this area out, but it is going to be a close one. All right, we got to get this wrapped up and rendered, or it's going to be late again. So let's take one last look at things. We do have some towers south of Memphis. So it is trying along the cap rock, a little bit east of the dynamics. And then checking back on that SPC mesoscale analysis, we are forming up kind of a mesolow just south of Amarillo, down around Palo Duro Canyon, and a little convergence starting to form right there. So, yeah, that kind of corresponds to that enhanced cumulus area we're seeing. And this is the diagnostic forecast field for 8 p.m. This is what it's expecting, and it's got all the convergence, everything piled up there. So if I was going to chase and take a chance on that triple point convection, I would probably be looking for the 287 corridor around Memphis. Looks like it's pretty slow moving. And that's how things look at this time. So that's how we put together a forecast with an event like what we have today. All right, well, time to start rendering this and get it uploaded as fast as I can. Wish we had a faster internet connection and faster computer horsepower, but we'll try our best. So that's all I got for tonight. We'll see you all tomorrow. Bye-bye.